All right, today we're jumping into the world of network navigation with IPv4 static routing. You can think of it as the original hand-drawn map for your data, from way before we all had a GPS in our pocket. Let's get into it.
I mean, have you ever really stopped to think about it? It's pretty amazing. When you send an email or you load a web page, how on earth does that little packet of information know which path to take when there are literally millions of possibilities?
Well, the thing is, your router doesn't just know the layout of the entire internet. It needs directions. And with static routing, a network administrator is the one providing those directions, manually. They're drawing a very specific, unchanging map for the router to follow, no questions asked. So here's what we're going to cover. We'll start with what static routing actually is, then we'll explore the different kinds of routes you can create, everything from the main highway to a backup detour. And finally, we'll talk about why this old-school manual method is still so darn important.
Okay, let's get right to the heart of it. What exactly is going on when an administrator decides to take the wheel and go manual?
See, with dynamic routing, routers are constantly chattering amongst themselves, figuring out the best paths on the fly. But static routing? Nope, it is a direct command. An administrator logs into the router and programs a direct order that says, to get to this destination, you must go this way. There's no debate, no negotiation. It is totally deliberate and precise. Now, this number 1 you're seeing, this is super important. It stands for the default administrative distance, or AD. The easiest way to think of AD as a trustworthiness score. The lower the number, the more the router trusts that path. And with a score of 1, a static route is one of the most trusted paths possible, second only to a network that is physically plugged right into the router itself. And this table here perfectly illustrates the trade-offs. Static routing gives you complete manual control, which is fantastic for security because the paths never change unexpectedly. It's also really light on the router's brain power. It doesn't need much CPU or memory. But here's the catch. It's really only practical for smaller, predictable networks. Just imagine trying to manually redraw a city's roadmap every time there's a traffic jam. That's what static routing on a huge network would feel like. It just doesn't scale. All right, let's talk about our first type of static route. It has a great nickname, the gateway of last resort, and honestly, it's kind of the router's safety net. So think about it. Your router's routing table is basically a list of specific addresses it knows. But what happens if a packet shows up for a destination that's not on the list? Without a default route, that packet is just dropped. Poof, gone. But with a default route, the router basically says, I don't have a specific instruction for this one, so I'm just going to send it down the main highway and let the next router deal with it. And this is the command that makes it all happen. Those 2 sets of all zeros, that's basically a universal wildcard that means any network with any subnet mask. And that next hop address part is just the IP address of the very next router in the path, the next stop on that packet's journey. Okay, so let's zoom in a bit. Not all static routes are these giant catch-all highways. Some are designed for entire neighborhoods, while others point to a single house. A standard network route is what you use to direct traffic to an entire subnet. So instead of telling the router how to reach every single computer in an office, you can just give it one simple command to reach the office network itself. It's a really efficient way to route traffic between different parts of your internal network. And here's what that looks like in the real world. The command points to the network address, that 192.168.2.0 part, and its subnet mask. This tells the router that any packet headed for an IP address inside that range should be forwarded to that specific next hop address. Simple as that. Now, a host route is the complete opposite. It is hyper-specific. We're not talking about a neighborhood anymore. We're talking about a single mailbox. This is incredibly useful if you need to force traffic for, say, a critical server down a very specific controlled path for security or maybe performance reasons. So the secret sauce here is the subnet mask. See how it's all 255s? Think of a subnet mask as a filter. A mask of all 255s is the most specific filter you can possibly create. It tells the router this rule applies to one and only one IP address in the entire universe, 10.2.1.2. There is zero ambiguity. Okay, so what happens if your perfect, hand-drawn route suddenly hits a roadblock? Well, this is where network admins get really clever with a pre-planned detour. A floating static route is basically a backup path that just sits there dormant in the router's configuration. It's held in reserve. And the whole trick is that the administrator manually gives it a higher administrative distance, making it less trustworthy or less preferred than the main route. It's the use in case of emergency option.
So let's just walk through how this plays out. Normally, all your traffic is flowing happily along the primary route because its AD of 1 is the most trusted. But then, disaster. The link fails. The router immediately sees this and yanks that broken path out of its active table. And in that very instant, the backup floating route with its higher AD becomes the best available option and traffic seamlessly switches over.
And here is the magic in action. The command looks pretty much like a normal static route, but check out that little number at the very end. By adding that 5, the administrator is manually setting the administrative distance to 5, which is worse than the default of 1. This guarantees it will only ever be used if that primary route completely disappears. Pretty clever, right? So you might be thinking, in a world full of smart, dynamic protocols, why are we still even talking about this manual method? Well, the answer really comes down to 2 words: control and predictability. Let's bring this all together. This table is a great little cheat sheet. We've got our default route, that's the main highway for any traffic you're not sure about. The network route gets you to the right neighborhood. The host route takes you to a very exact street address. And finally, the floating route is our pre-planned backup detour. Each one is a specific tool for a very specific job.
When it comes down to it, static routing gives you absolute control. You know exactly where your traffic is going. It's secure because there are no surprises. The paths don't just change on you. It's efficient because the router isn't constantly working to figure things out. And for simple, predictable networks, it's just a rock-solid, straightforward way to manage everything.
I love this quote because it just perfectly sums up the whole philosophy. When an administrator configures a static route, they aren't just suggesting a path. They are making a definitive statement about how their network should operate. They're the architect, drawing the map themselves. And that really leaves us with a final question to chew on. In that balance between the precise control of drawing the map yourself and the adaptive freedom of letting the network figure it out automatically, which approach would you trust with your most important information? Something to think about. Thanks for joining me.